to decrease the voltage. Actually what happens is, in power plant, the basic work of a power plant is to what?
Generate power.
Yes. Or which kind of power? Electricity, right? So it's basically generation of electricity. So like the electricity that is being supplied to at our home, that makes us able to run our appliances, are basically produced in power plants. Okay. Now
Okay.
the work of power plant is just to produce electricity. But this electricity sorry, and this electricity is then supplied to our home with the help of national grid. Okay. So
Mhm.
national grid basically has transformer and all the cables required to transfer the electricity. They have the transformer. Actually, the electricity that is being produced in a power plant is at very high current and high voltage. Okay. But if you supply this power with the cables, we have studied P is equals to V multiplied by I, right? Or I squared R, right?
Yeah.
So this means if there is an increase in current, the current is high, so power will be way high and heat generation will also be very high. So higher is the voltage, higher will be the current, and higher is the heat generation. So there is a chances of getting, like, there's a chances of accident, or these wires gets melted. That's why when they supply current, they use a transformer to change the voltage. Okay.
Mhm.
So that the frictional losses can be minimized. And when they reaches to our home, there also are the transformer which changes the voltage according to the requirement of the homes. Okay.
Okay.
So that's the basic work of a transformer, that is to increase or decrease voltage. Is this
Okay.
clear?
Yeah. So the purpose is to increase and decrease voltage.
Yes. Now if we see the structure of a transformer, the transformers works on the basis of, or on the principle of, mutual induction. So first tell me, what do you mean by induction?
Induction. So induction is um. Let me see. Um, the phenomena of showing magnetic properties under the influence of current and electromagnetism.
Induction is actually inducing of voltage. You remember induced EMFs I told you? Like if there
Mhm.
is a coil and you move a magnet inside and outside the coil very rapidly, because of this magnetic field rotating, moving magnetic field, actually what you are doing, it's a magnetic field but it's a static. That means when magnet is not moving, its field is static. When you start moving the magnet, the field around that magnet also starts to move, right?
Okay.
So because of the motion of magnetic field, it produces an electric field, or it induces a EMF inside this coil. Is this clear?
Mhm.
This is known as induction. So simple, when a magnet is moved inside and outside the coil very rapidly, this produces or this induces EMF in the coil. This process is known as induction. Clear?
Okay. Yeah.
So transformer works on the basis of induction. that is mutual induction. Mutual induction, which means suppose this is a coil and there is another coil. Previously, a magnet is inducing a EMF inside this coil, but here this coil actually transfers or induces EMF in this coil. That is, when one coil induces EMF to other coil, that is known as mutual induction. Okay.
Okay.
So when a magnet is inducing EMF in another coil, in a coil, that is known as induction. When one coil induces EMF in another coil, that is known as mutual induction.
Okay.
Okay. So the transformer works on the principle of mutual induction. How? Let me see. So suppose this is an iron core. Okay. So this is basically an iron core. Now you wrap a coil around it. So basically we take soft iron, right? Then we take a copper wire, a conducting wire, and we wrap this coil around it. Like this. And same is done here. Okay. So around this iron block or core, a copper wire is wounded. Now what happens is, its one end is connected to AC input, which means, see, the first thing that I have to clear is, the transformer is what? It's a device that can change the potential difference or voltage, okay, of an alternating current. There are basically two types of transformer. One is known as step-up transformer. Second is a step-down transformer. Step up, which means it increases the voltage. Okay. So that kind of transformer which can increase the voltage is known as a step-up transformer, and those kinds of transformer that decreases the voltage, that's why it's known as step-down, are known as step-down transformer. Okay. And you have to remember, it's always the alternating current that is being supplied to the transformer, okay, that is used to change the voltage, because in our home it's the alternating current that we use, or that the appliances in our home uses alternating current, not the direct current, okay, that is AC current. Clear?
Mm-hmm.
So this is AC input. AC input, which means basically its work is to increase or decrease the voltage. So you have to supply that current, the current you want to decrease its voltage, right? So that
Uh-huh.
is that suppose this current is coming from the national grid. Okay, they are supplying, or from the power plant, they are supplying that electricity to distribute. So this end is that where it's a AC input. Okay. Now
Mm-hmm.
what happens is, when electricity starts to flow through this coil, electric field is generated. Is this clear?
Yeah.
And it starts to behave like an electromagnet. Clear? Because in the electromagnet was the same. There is an iron core and you wound a copper wire around it, and when you start supplying current electricity, then it starts behaving as an electromagnet. Okay, same thing happens here. When electricity is being supplied, electric field is generated, and because of that, this part of iron core starts behaving like that of an electromagnet. That means now it has magnetic field as well. Okay.
Yeah.
And since I've told you, now this part has electric field plus magnetic field. Now since I've told you that this produces both kind of field, and it basically works on the principle of what? Mutual induction. That means one coil can induce voltage in another coil. So this coil has magnetic field or EMF, we can say. Now this coil actually induces EMF in this coil. Okay, that means
Okay.
now it has potential difference. If any wire or anything has potential difference, that means current starts to flow. Okay, you just need to supply a potential difference, automatically current will start to flow. Okay,
Okay.
so it has EMF, then the current starts to flow through this coil. Okay, this means now it also has electric field. Okay, because current is
Mhm.
flowing through this coil, and if it has electric field, this part also starts behaving as electromagnet. It has magnetic field. That means both the sides now have electric field, magnetic field. They both have electric current. Now see how it actually changes the voltage. There is a relation, and according to this relation, it is voltage in primary coil. This coil is known as primary coil, and this coil is known as secondary coil. So voltage in primary coil divided by voltage in secondary coil is equals to number of turns in primary coils divided by number of turns in secondary coil. Okay, which means
Okay.
if you remember, I told you when we were doing in induction, I told you how to increase the induced voltage by increasing the number of turns, right? That means
Yeah.
they both are proportional to each other. If you increase the number of turns, voltage increases. If you decrease the number of turns, voltage decreases. Now you tell me, if it's a step up transformer, that means you have to increase the voltage. Increase the voltage, which means suppose voltage here is V1 and voltage here is V2. That means you want V2 be greater than V1. Is this clear?
Yeah.
So will you increase the number of coils here or here?
So that's the first side is V1 and the second is V2,
Yes.
and you want more voltage in V2, so you increase the number of volts of coils in V2.
Yes, that's very correct. So that's how this transformer works, which means if you want to increase the voltage, the number of coils will be larger here. Okay, and if it's step down transformer, that means number of coils will be larger here or here lesser, right?
Okay.
See, if you want to decrease the voltage, so if you want to decrease the voltage, which means you have to decrease the number of turns, right?
Mhm.
Are you sure? Is this clear?
Yeah. Yeah.
Okay, so then number of coil turns should be lesser than number of turns in primary coil. Okay, so by changing the number
Okay.
of turns in a coil, a transformer can behave as step up or step down. Okay,
Okay.
so you just write it down whatever you understand this. So first what you have to write, let me give you. First write this one that I have written, the induction and mutual induction, its definition. Okay,
Okay.
then you write the definition of transformer, which means a device which is used to increase or decrease voltage. That is the
Okay.
definition of transformer. Then two types of transformers, step up, step down. Its definition. Then here it's you have to draw its diagram, the relationship, and then I'll tell you the steps how it works. Okay. As of now,
Okay.
you note it down this.
So transformer is a device to.
Which is used to increase or decrease the voltage of an alternating current. That's very important, right? Of an alternating current.
So the induction, the definition of transformer, the two types of transformers,
Yes.
and what else?
Yes. So you have written induction, mutual induction, and transformer. You have to write,
Yeah.
and then you have to write principle of transformer is that it works on the principle of mutual induction.
Okay, the principle of mutual induction.
After this, draw this diagram and write the formula, like the relationship. Okay.
Okay. So what was the mutual induction principle again?
Yeah, I've written it here. You can see
Oh,
when one
oh
coil
right.
induces EMF in another coil, right?
Okay, yeah, I've got that done. Okay, I've got it all done.
Okay. Now it's working as I've already explained you it's working, but let me write point by point. So first thing what happens, it starts with the primary coil. Okay. So
Mhm.
a primary, that means on left hand side you can see. So a primary voltage drives on alternating current through primary coil, which means at the first it's the primary voltage developed. So when current, because this is an AC input, so when current is supplied, a primary voltage is developed or it's already there. Okay.
Okay.
And the current passes through this primary coil.
Okay, so in the primary coil, the primary voltage is developed.
Yes. Or you can say basically a primary voltage results in passing the primary current. In both ways you can tell, both are same.
Okay.
Now what happens, because of that voltage, okay, actually it's being supplied more, like more properly or more accurately rather than developing. It's, you can see when primary voltage is supplied, then current passes through the primary coil. Okay, so you can
Mhm.
write supplied, that will be a better word. Okay, so
Okay.
then what happen is the primary coil current, that is current flowing through this primary coil, produces magnetic field. Okay, because it has already electric field, but this produces a magnetic field. So primary, in primary coil, because of current, magnetic field is produced. Okay, now here is, because of this magnetic field or because of the changing magnetic field, okay, what happen is
Mhm.
actually this iron core increases the strength of magnetic field. That's why we use iron core. Okay, so this iron core increases strength of magnetic field. MF stands for magnetic field. Okay, I'm writing it in its short form. Then because of this changing magnetic field. Changing, which means because iron core has strengthened it, that means its intensity has changed. So because of changing magnetic field, it induces a voltage or potential difference. PD is what? Potential difference in secondary coil. Now, because of this induced EMF in secondary coil, an alternating current has produced. Okay. And now changing the number of coils in secondary circuit or in primary circuit, we can increase or decrease the strength of voltage. Okay. So this is the working. You write that completely, and then we'll do questions on transformer. Okay.
Okay. Okay, done.
Good. We can also have sent you that pic. You first tell me which questions am I supposed to solve.
Oh, just 7.
Question number 7th,
Mm-hmm.
or only 7th.
Yeah, just 7. I needed you to solve 7 for me because I didn't know how to solve it.
Okay, okay. Okay, now let me see. Let me do a question, okay?
Mm-hmm.
So this relation we have to use what? As voltage in primary divided by voltage in secondary coil equals to number of turns in primary coil divided by number of turns in secondary coil.
Mm-hmm.
Now the question is, a mains of 230 volts transformer has 11500 turns on its primary coil, okay, and
Okay.
600 turns on secondary coil. Calculate the voltage obtained from the secondary coil. So you have to calculate the voltage on secondary coil.
Okay. So the voltage of the secondary coil then?
Yes, you have to calculate the voltage on secondary coil.
Okay. So Vp over Vs equals Np over Ns.
Yes.
Um, Voltage of the primary coil is 230,
Yes. Okay.
and the voltage on the secondary is X.
Yes.
So um, and the number of turns on the primary coil is 11,500,
Yes.
and on the secondary it's um, 600. So 1,000, 11,500 divided by 600 is 19.16,
Yes.
um, and 230 over, which is equal to 230 over x. So we divide 19.16 over 19.16 by 230,
Yes.
which is 0.083 recurring.
0.0.
So
Yes.
yeah,
So what's your voltage?
um, the my voltage is um, um, 0.083.
Okay, this seems great. See, in place of primary voltage, you have to write 230, right? So it's
Mm-hmm.
230 is divided by, let it be x. Primary is 11500 and in secondary is 600. Okay. So
Okay.
x is equals to what? You just have to cross multiply. So it's x multiplied by 11500 equals 230 multiplied by 600. Okay.
Okay.
Now calculate the value of x.
X is 12 volts.
Yes, that's right. It's 12 volts. Okay.
Hmm.
Okay, now the next question. Okay. It's given as number of turns in primary coil is given as 10,000 and number of turns in secondary coil is given as 250. If voltage on secondary coil is given as 10 volts, you have to calculate voltage on primary coil. Okay.
Okay. Okay, so the um, primary voltage is 400 volts.
Yes, that's right. And the last question on the same. It's given as the primary voltage is 200 volts. Secondary voltage is given as 20 volts. If number of primary coil is 1000, calculate number of secondary coil.
Okay. So the primary voltage is 200 volts.
Yes.
Okay. X is 10 volts.
You have to calculate number of turns.
Oh, sorry. I mean 10 turns.
Okay, so it's 10. Your answer is.
Yeah.
I think you need to resolve once again. See, but I think you are doing some mistake.
Okay. So the primary voltage is 200. Um, Secondary voltage is 20. Number of primary number of turns in the primary coil is 100, and number of turns in the secondary coil is X. So it's going to be 200 over 20 equals 100 over X. And
Yeah.
then we cross multiply. So we get 200X equals 2000.
Yeah.
And then,
See, you can. Yes, you can do in both ways. Continue.
okay, and then we divide both sides by 200.
Yeah.
And um, and we get X is 10.
I think you are doing some mistake. There must be one more zero.
Oh, okay.
So let me write this one down.
Oh, alright then.
I'm just writing it. So it's 200 divided by 20 equals 1000 divided by x, right? That means it's
Mm-hmm.
200x is equals to 1000 multiplied by 20, or x is equals to 1000 multiplied by 20 divided by 200. So 10101010. Okay, it will give you 100 number of turns, not 10.
Okay.
Clear?
Yeah.
Okay, now there is a next relationship between the current and the voltage. Now the most important thing is power remains the same. You can clearly see that the voltage is changing, right, in primary coil and
Mm-hmm.
secondary coil, but power
Yeah.
remains the same. Like if you see in whatever the power is in primary coil, the same value is in secondary coil. That means P1 V1 is equals to P2 V2, right?
Yeah.
Sorry, I1 V1. Power is equals to what? V multiplied by I, and power
Mm-hmm.
in primary coil is equals to power in secondary coil. That means V primary multiplied by I primary is equals to V secondary multiplied by I secondary. Okay. So
Mm-hmm.
this is the next relationship that you have to use in order to calculate the whatever in the question. So
Okay.
the question is, a step down transformer converts 11500 volts into 230 volts. Okay, this means it's the primary voltage, it's the secondary voltage. Clear?
Okay.
Now the power output used to run, okay, as of now it's difficult. Okay, so 11500 volt as the voltage in primary coil and 230 volts in secondary coil. If the current flows in a primary coil is 100 amps, calculate the current flowing in secondary coil. Okay.
Okay. Okay, so X is um, 5,000 amps.
Okay, so voltage in primary coil is given as, and you have to calculate the voltage on secondary coil, right? Yeah. So what's your answer?
Uh, we were calculating the
Current in
weren't we
secondary coil.
calculating the current
Yes, in
on the
secondary coil.
secondary?
Yes.
Okay. So for the secondary coil, I got 5,000 amps.
Yes, that's very correct. Okay, now you see I've sent you the solution for question number 7.
Okay, thank you.
Okay,
Hmm.
so you see that, and even if you have a problem, you can ask me about that. Okay,
Okay.
so I think that's it for today because the next topic is big, like it's bigger. So it's better if we start in the next class. Okay.
Okay.
So you just open it and read it. If you have any problem, you can ask me if you can't
Okay.
understand it. So just let me clear
Hmm.
you the question quickly. Actually, it's the question is that Jake has some money. So we have assumed that Jake has X money. So Ken has 4 times. That means it has 4x money. Okay.
Okay.
Now since he gave 360 to Jake, that means if he is giving 360, now he has 4x minus 360. Okay.
Hmm.
And Jake is receiving, so now he has extra money, that means x plus 360. But still Kane has more money, that means inequality sign is 4x minus 360 greater than x plus 360. Is it clear?
Yeah.
Okay, so that's it, and we'll continue this chapter in the next class. Okay,
Okay. Thank you.
thank you, bye.
Bye.